Just want to put this resource out there as another way that we could kind of identify and look for these things that Miss Murphy was covering earlier this year, and then as we move forward. So as we start looking at different equations, different relationships, different ideas that connect between data, graphs, tables, all that things, we need to understand the ideas of slopes, and now I'm going to introduce intercepts. So we've spent quite a bit of time on slopes in the past, at least that's what kind of you showed me in your previous work and what Miss Murphy was communicating. We're going to also introduce what's called an intercept and then really open up a lot of different ideas for a lot of different scenarios about how we can start to connect real-world situations to tables, equations, and graphs and represent things algebraically. As a quick recap, we have slope written in a lot of different ways. So we have ways to calculate slope as rise over run. We also talked about finding the rise as looking at the change in the y's, or y2 minus y1, and then looking at the run as the change in the x's, so x2 minus x1. And if we were looking at that as ordered pairs or on graphs, say for instance we saw a graph that had data points at 2, 4 and 3, 7, sorry that is super hard to see, at 3, 7, we would then look at our y values, which we have here, and I'll do those in yellow. We would look at our x values, which I have here, and I'll do those in red. So as we look at those underlined values, we're looking at subtracting the y values and subtracting the x values, which if we were on a graph would be how am I rising and how am I running in order to connect those 2 points. So if we're looking at that equation, I'd start to say, okay, well, y2, the second y value is 7, minus the first y value is 4, and I'm going to put that over the second x value, which is 3, minus this first x value, which is 2. Here, I'd get myself a slope of 3 over 1, because 7 minus 4 is 3, 3 minus 2 is 1, 3 over 1. As I was looking at a graph, if I was to graph a slope of 3, 1, and this is very rudimentary just because there's no grid paper yet, but I'd be looking and saying, okay, if this is my first starting point, I'd have to go up 3 data values, so 1, 2, 3, and then I'd have to go over 1. So I'd run by 1, so over 1. So if I went up 3, 1, 2, 3, and over 1, my new data point would be right there, and I could connect that on a graph in order to make that representation kind of move forward. So we have this idea of slope, rise and run, changes in y's, changes in x's. We'll keep practicing those as we need to. As I introduce these next concepts on intercepts, this is another thing that we can look for in a graph. And what's going to boil down to is what does it really mean to intercept? What I know about intercept comes from the world of football, and here's my terrible football to start. And when I think of intercept, I think of an interception. And when an interception happens, you have a football being thrown to a receiver, and somewhere in that mix, you have a defender that comes and kind of crosses the line that was intended to be going from the ball to the receiver. So really an interception is kind of like an intersection. It's where 2 lines or 2 paths cross. So when we think about intercepts, we think about where things cross. And if you think about that in football, it kind of makes sense because an interception happens when a defender crosses the path of the ball going to the person on offense, where things cross. When we look at intercepts on graphs, I'm going to talk very specifically about things called a y-intercept. And when we think about that, a y-intercept, we should have our brains kind of moving to, when we think y, the y-axis. So on a graph, if this is my y-axis, this is my x-axis, a y-intercept is a line that crosses the y-axis at some point. So looking at that point right there, this red circle would be the y-intercept. It's where this red line crosses the y-axis, where it intercepts the y. It'll make a lot more sense when we have values on things, when we start identifying y-intercepts with numbers. But if I have another graph there, I have a y-intercept at that point. If I have this green, really hard to see one, I have a y-intercept there. And then if I have this yellow line there, I have a y-intercept there. Wherever my line, my data, is crossing the y-axis, that's a y-intercept. So now what we're going to start to connect is this idea called a slope-intercept equation. And this seems going to seem overly complex, but when you really break it down, it's really not. The very baseline system of a slope-intercept equation starts with a y and an x. And this always comes from our ordered pairs. But where the equation comes in is we add in equals m, and m we know is a slope. because we've seen those kind of coming in the past of rise and run, y equals mx, stuff like that. And then when I also add the intercept, because I have a slope and I have an intercept, I'm going to add on this value saying plus b. And this b is going to be representative of a y-intercept. So you're going to see things that come into an equation that look things like y equals 1/2 x plus 3. And then what you'd simply tell me on something like this is, okay, well, I see this equation, and I see that I have an m value, so I know in this case my slope is 1/2, because it's in this position where the m would be in a slope-intercept equation. I also know that my y-intercept is 3, because I have this 3 kind of finding this value in that b position. And b is just a symbol that is being used. There's really no direct connection to it. It's the most commonly used symbol to represent y-intercepts. But I haven't really ever seen a connection about why the letter B. It's just what I've always seen as most commonly used and easily communicated to other people about a y-intercept. And so now if we look at this one, we can say, okay, well, I have enough information where if I know the slope and the y-intercept, I can make graphs, I can make data, and I can make tables. We'll get to that as we continue, but that's for a later time. But it's really identifying in this idea of a slope-intercept equation where we start to see those two identifiers, slope and then the y-intercept. As I was stating before, there's different y-intercepts, and in those y-intercepts, you have places where your data lines cross your y-axis. So in this case, we have 3 different data lines, the blue, the yellow, and the red, and we have 3 different positions where they cross the y-axis. Blue crosses the y-axis right here, yellow crosses the y-axis right there, and red crosses the y-axis right there. So if I was looking to identify my y-intercepts, I would say that in blue, there's a data point here at 0, 6. And you might say, well, what are you talking about 0? Well, if I look and I start to think about this x-axis down here, I would start putting in values like this, 1, 2, 3, 4. What I know for sure is that this line that I'm highlighting in blue is the y-axis. We also know that it will always have a value of 0 when we're talking about coordinates. So if I'm thinking about 0, 6 as my value, I know that's 0 on the x-axis and 6 on the y. So if I don't move at all, I know I would be plotting that point right there at 0, 6. And that's going to be something that's going to be always identifiable about a y-intercept, is that it's always going to have a value of 0 when it's relating to the x in our coordinates. That's probably a little bit more than we need to talk at this point, but really we just know that the y-intercept in this case for the blue line is 6, because at 6 is where the blue line crosses the y-axis. For the yellow line, it would have an ordered pair of 0, 4, because the yellow line crosses the y-axis on the number 4. So it would have, if I was plotting this data point, it'd be 0, 4. I'd go over 0 and up 4 in order to plot that point, which would end up right here. Then lastly, we do have this bottom section, which is in the red graph, would give me a y-intercept of 0, 2. Or I could just say the y-intercept is 2, because this red line here crosses the y-axis at 2. So we start to see where does this data cross the y-axis, and we can start to interpret what those intercepts really, really are.